Alright, so in this video, I'm going to solve the equation x to the power of 8 is equal to 25 squared. So to solve this, I'm going to first rewrite this as x to the power of 4 times 2 is equal to 25 squared. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 4 times 2 is equal to x to the power of 4 to the power of 2, and this is equal to 25 squared. Now I'm going to subtract 25 squared on both sides. So these two cancel out, and I get x to the power of 4 to the power of 2 minus 25 to the power of 2 is equal to 0. And before we actually do this, I'm actually going to take the square root on both sides so I can cancel these 2's out. So I get x to the power of 4 minus 25 is equal to 0. Now from here, I'm going to rewrite this as x squared to the power of 2 minus 5 squared is equal to 0. So now I can use the formula a squared minus b squared is equal to a plus b times a minus b on this. So this turns into x squared plus 5 times x squared minus 5 is equal to 0. So I get two equations. X squared plus 5 equals 0, and x squared minus 5 equals 0. So for x squared minus 5 equals 0, I get x squared equals 5. If I take the square root on both sides, I get x is equal to positive or negative square root of 5. Now for x squared plus 5 equals 0, I can subtract 5 on both sides. So I get x squared is equal to negative 5. If I take the square root, I get x is equal to the square root of negative 5, which is equal to the square root of 5i. So these are my four solutions to this equation. Alright, so in this video, I'm going to solve the equation x to the power of x is equal to 3. So, to solve this, I'm going to first start by taking the ln, or natural log, on both sides. So I get ln of x to the power of x is equal to ln of 3. Now, an important property of logarithms is that if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this turns into b times ln a. So in this case, I have ln x to the power of x, and I can move x to the front, so I get x times ln x is equal to ln 3. Now, I'm going to use an important formula called the W-Lambert formula. And it states that if I take the w of something in the form a times e to the power of a, then this is equal to a. So this is the W-Lambert formula. So in this case, I'm going to rewrite this so that it suits the W-Lambert formula. So we need to change this to be in the form a times e to the power of a. Well, how am I going to do that? Well, I'm going to first start by rewriting this x as e to the power of ln of x, because x, e to the power of ln cancel out, so that's just x is all that remains. So x is the same thing as e to the power of ln x, and I have this times ln x is equal to ln 3. So now notice how this is in the form a times e to the power of a. A in this case being ln x, so it's the form ln x times e to the power of ln x is equal to ln 3. So now if I take the W-Lambert function on both sides, I get w of ln x times e to the power of ln x is equal to ln 3, and this is just equal to a. So, and sorry, I have to take the w on both sides, so I get w of ln 3, and then now I'm left with ln of x is equal to w of ln 3. Now, I want to get rid of this ln, so I'm just going to take e to the power of both sides. E to the power of ln is, these two cancel out, so I get x is equal to e to the power of w of ln of 3. So this is my answer to this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and check out other videos that are similar to these on my channel. Thank you.